In this video, I'll show you how to convert between the polar and Cartesian form of complex numbers. So let's start by going from polar to Cartesian, and we'll have a number re to the I theta, and remember that this is the polar form of the number. Now the idea here is that we're going to use Eulers Formula, which allows us to rewrite e to the I theta as cosine theta plus I sine theta, to rewrite re to the I theta, the complex number we start with, as r cosine theta plus ir sine theta. And this is the Cartesian form that we want to end up with. Let's do an example. We'll start with 3 e to the I pi over 6, which is currently in polar form. And then, using Euler's formula, we can rewrite this as 3 cosine of pi over 6 plus I times 3 sine pi over 6. And this is actually already in Cartesian form, but we can take it one more step and write it as 3 and actually evaluate cosine of pi over 6 and sine of pi over 6. So it's 3 times square root of 3 over 2 plus I times 3 times 1/2. Now let's go from Cartesian to polar. We'll start with some number a plus bi, and this is the general way in which we write the Cartesian form of a number. Now the goal of this is to rewrite it as re to the I theta, which is, of course, the polar form. The problem is, how do we figure out what r and theta are supposed to be? I'll show you. Let's build a complex plane, and now we'll start with an arrow representing some complex number. Since we're starting with Cartesian form, we want to describe this arrow in terms of how far we walk along the real and imaginary axis. So let's build a triangle. And assuming that this arrow represents our number a plus bi, this means that the horizontal length is a and the vertical length is b. Now how does r and theta fit into this picture? Well, r is the length of the hypotenuse, and theta is how much this arrow has been rotated. So now let's do some trigonometry and figure out how a, b, r, and theta are all related to each other. First, let's use Pythagorean theorem and point out that a squared plus b squared is equal to r squared. So this tells us that r is equal to the square root of a squared plus b squared. And then let's point out that tangent of theta, so tangent of theta is equal to the opposite, that's b, is equal to opposite divided by adjacent, which is a. So we can write theta is equal to arctan of b over a. Let's try to convert the number 1 plus I into polar form. I'm going to sketch a complex plane. And let's put a 1 here and an I there. So our number is pointing from there up to here. And let's see if we think about it in terms of Cartesian form. We have a right triangle, and this side is length 1. And this side is also length 1. And remember that this will be r, and this angle will be theta. So let's see. R here is equal to the square root of 1 squared plus 1 squared, which is equal to the square root of 2. And well, tangent of theta is equal to 1 over 1, which is equal to 1. That means theta is equal to arctan of 1, which is equal to pi over 4. So combining these two things, so we have r is equal to square root of 2, and theta is equal to the pi over 4. We can write this as square root of 2 e to the I pi over 4. So that's 1 plus I in polar form. And I think that's where I'm going to end this video.